wear a different hat. Yeah, and a different shirt, which is a slightly different color of bluish purple on us. What's new and free from IRIS? How many folks are familiar with IRIS? Okay, you can go home. So what's new and free with IRIS? New, lots, free, everything.
You need the microphone, Don's here.
Thanks for coming. Well, I do improv, and the last rule of improv is there are no rules. So I can hold the microphone, but I'm going to walk around a lot. So I'm going to talk loud with it. But yes, everything is free because IRIS is sponsored mostly through NSF funding. So we produce educational materials, and we want you to use them because you've already paid for it, basically. Okay? So what is IRIS? IRIS is Incorporated Research Institutions for Seismology. We're earthquake guys. Yeah, we're a consortium of universities that do geophysics research. IRIS itself does a bunch of things. We help the consortium do professional research. We have an instrument loan center in Socorro, New Mexico called Pascal, where if someone wants to propose a geophysics project, rather than having to buy the equipment themselves, they can loan the equipment from us, and the cost to NSF is much cheaper than it would be otherwise. And in Seattle, we have a data management center that stores the entire world's database of earthquake data from folks. And it's freely available. You can go online and download earthquake data and do research if you want to, or stare at pretty wiggles, or download some wiggles and put it into your Audacity and hear the earthquake, if you want. Kind of stuff. And then, of course, we do education and public outreach. So that's the part that I do for all those things. So one of the projects that IRIS works with is called EarthScope. This is my prop here, EarthScope. Kind of like the Hubble Space Telescope, but instead of looking at space, we look at Earth. EarthScope. Okay. Someone spent a long time thinking about that. Okay, so last year, Popular Science had a contest to find the world's most epic research project.
It's funny.
And the results were legend, wait for it,
Dairy.
EarthScope was rated #1 based on their criteria, which was number of people affected, the actual cost, the actual size of the experiment. We beat out stuff like that machine over in Europe that looks for little tiny things, but costs a lot of money. The LIGO thing that's looking for maybe non-existent stuff. Yeah. Or maybe it is. We don't know. We haven't found anything yet. But EarthScope was rated most epic because it covers the entire continent of North America at some time or other with it. If you have not heard of EarthScope, it is the most epic science project that nobody's ever heard of.
That's hysterical.
Anyway, so one part of EarthScope is called US Array, and that's the part that you should concern yourself about because that's the part that's on the East Coast. US Array is a very dense array of seismometers that is traveling across North America to learn more about the underlying structure of North America. So much like when you have a digital camera, if it has 6 pixels, you don't sell those pictures to anybody for a profit, if you're Duke Johnson, who makes those nice nighttime skies. If you have 25 megapixels in your camera, then you get lovely nighttime shots of national parks with stars, and you make some money off of it. Okay? The same thing with learning about the interior structure of the Earth. The more seismometers you have squished together, the better the resolution is for what's under the place where the seismometers are. So, in 10 years, the seismometers will travel across the entire U.S. There's 2,000 sites. We don't have 2,000 seismometers, and they don't stay there forever. Why not? No money. Yes, it's expensive to do that. So NSF was willing to fund 200 seismometers that would stay in place for 2 years, and then you take one off the west side, put it on the east side, go back to the west side, take another one off, and just keep moving across until you get through the whole country. And since they stay there for 2 years, they're able to detect earthquakes from all around the world. So seismic waves are coming up from all different directions over the 2 years. So you compile all that data together, and you now start getting like a CAT scan of what's under North America, which is cool. Okay, so why should you care? Well,
Yeah.
yeah, there's how we got sites for it. All right, why should you care? The red dots are where US Array currently is.
Nice. Right now.
So why should you care?
Looks like
They're coming. Or they're already here. They're in your backyard. Each of the seismometers in US Array are spaced 70 kilometers apart. So for the next 2 years, you and everyone who visits your museum and every school kid near you will be no further than 35 kilometers from a professional earthquake detecting research instrument in their backyard. So why should you care?
you get one in your backyard?
You can't really get one in your backyard.
Oh.
But when we put all the seismometers in on the West Coast, people were not excited much. I mean, there were people who were excited, but most folks weren't excited because they're like, yeah, it's California. We got seismometers here. You gonna put some more in? Why? You know. When it got to the middle of the country, well, yeah, New Madrid's in here. There were some big historic earthquakes in New Madrid. But as it's coming east of the Mississippi, people are getting much more interested in why are you putting a lot of seismometers on the East Coast? We don't have earthquakes here. We do, especially the Virginia earthquake, and that got a lot of interest in it. So for the next 2 years, there's going to be earthquake detecting stuff near you, in your backyard, with it. And the news media is going to call your museum. And they're going to say, hey, there was a huge earthquake in Japan. I understand there's this project that has all these seismometers around. You're the local earth science expert. Could you tell me about it? And you're going to say, oh, crap, I should have listened to Patrick's talk and I should have gone to his website before now. Because they're going to show up. So for the next 2 years, you have a chance to be the earthquake expert in your area. Contact the media before the big earthquake happens and say, US Array is coming, or here already. We know about it. If you want to come talk to us about earthquakes, we'd be happy to chat with you. So now they'll call you for eclipses and rocket launches and earthquakes, okay? Because you do earth science, okay? Now, how do you become an earthquake expert?
Go to your website?
It's a long, tedious process. No, it's not. We make it easy for you. Go to our website. We have lots of resources to help you become an earthquake expert very quickly.
Hey, we know those people.
Yeah, so like here's some folks that are already earthquake experts. They were doing a little activity at a prior MAPS conference where they were locating earthquakes on a globe. Because earthquakes happen on globes, not flat Mercator projections. So a little more realistic for kids with it. So we do all kinds of stuff. So one of the things that you should look for is our recent earthquake teachable moments resources. For every magnitude 7 or larger newsworthy earthquake, within 24 hours of that earthquake happening, we will post a PowerPoint on our website that you can download that compiles all the information for that earthquake.
Wow.
The historical data information about how earthquakes happened there in the past. What's the fault mechanism in that area? How big was it? How many folks felt it? What was the damage? What's going on there? And little animations that show stuff. We have lots of really cool animations, so when the news media calls up and says, you got anything you can show us? Because we're like TV. People want to see something. They don't want to hear you just talking. They want to see the earthquake happening. We have that stuff too. So if you download the PowerPoint, you can use it in your programs. So if you have school kids coming in and they've heard about this big earthquake, there's a good teachable moment. And they'll say, wow, how did you know all that about earthquakes? You can say, well, because that's what I do. I know about science. And I got up half an hour earlier and I downloaded the PowerPoint. Woo, thanks. So do that. So those are out there. Okay, and then we have lots of animations. And I'm not sure why it's doing it this way, but oh yeah, our animation team is getting close to what they do at NASA. So we've got 3D modeling programs that help model actual cities. Because it's real important to be accurate when you do these things. Up there. Oh, our budgets are not as huge as they used to be, but we use our funds wisely.
And this is silent Lego.
So when there's typically what your earthquake looks like. Don't ride the train. Now wait for your earthquake.
Is it the ground shaking or the camera?
Yeah. find lots of silly stuff. So what kind of stuff do we actually have? Well, we actually have animations that teach one concept at a time. One thing. So if you're learning about divergent plate boundaries, that's all it talks about, is divergent plate boundaries. Nothing else. So we try to keep it simple. They're like 30 seconds to maybe 2 minutes long. So if you're doing a program about plate tectonics or earthquakes or earth science or what happens on the Earth compared to what happens on Venus or Mars, you could download a little video. And then we do sort of comparison things because we do a lot of multidisciplinary type stuff. So I'm a physics teacher. I don't do earthquakes. Oh, yes, you do. You teach waves. You teach earthquakes. Okay? So we have a bunch of activities that are earthquake-themed physics problems because it's physics in there. So one of the concepts that's hard for most folks to realize, if I can get it to play again, perhaps, is much like people are familiar with ripples in a pond when you throw a stone in, seismic energy goes out the same way in all directions. Down, and then it reflects off everything that it hits in there. And that's partly how we figure out what's below the Earth when they have different densities and interfaces. Yeah, so it reflects and stuff. So lots of cool animations. How much do the animations cost? Cheaper than a full dome video show. Free. So use them. Download them. Use them. Okay. So when the news media shows up and they say there was a huge earthquake, can you show it to us? Well, it happened early this morning. So how am I going to show you nothing? You can. You can go to our website and go to the US Array ground motion wave visualizations, because for every earthquake that's detected by US Array, we create one of these little movies. So what are you seeing in the movie there?
Virginia.
There's Virginia. Okay, so this is going to be the Virginia earthquake that happened 2 years ago, which was the earthquake felt by the most people ever. From South Carolina up to New York, Ohio.
I thought my car was going to bed and I was oh God, what we have to pay.
So let's see. Each of the dots is one of the seismometers. So when I run the video, what you're going to see is some weird colors in there. If it's the dot turns red, that means the seismometer moved up. If the dot turns blue, it means the seismometer moved down. Okay, and this is actual data from the earthquake. So
would this be real time or slowed down?
it's sped up because real time would be a couple minutes, and here's the time frame down the bottom.
Cool.
So 20 minutes of time. So what are you going to see? Well, you tell the news media seismic energy goes out in all directions. Well, I got to be here somewhere. I got to push the button. Right? So seismic energy goes out in all directions. And they go, yeah, sure, all right, I don't understand what you're talking about. Okay, so you show them. And it's got to be good because it's endorsed by Phil Plait. He was blown away by the animation. He was. Okay, so what happens? Okay, so the earthquake happens, and there's the P waves, there are the S waves going across US Array. So you can actually see how it's going out in all directions. And then there's some science in here, too, because look what happens down in New Orleans. It's Mardi Gras. So it's, woo, yeah. No, this area has a lot of sediment, so once it starts shaking, it takes a while for it to settle down. So yes, there's some science in there.
What is the yellow thing in the very middle of that?
The yellow thing in the middle is the station that we're seeing here.
Oh,
So there's the seismic data from this particular station right here.
Oh, that's
So there's the benefit of having a dense array of instruments somewhere. You start getting resolution you didn't see before. So these are all available on the website too. So if there's a big earthquake, download the video, download the teachable moment, watch it, read it real fast, and then wait for the media to call you. Because before the earthquake, you let them know that you are a contact point for earthquakes. And they will probably not ask you any questions that you can't answer from our stuff. If they do, email me after they leave and say, they had this tough question I didn't know the answer to. Could you tell me that so next time I can answer it? But they do the same thing for earthquakes they do for astronomical events. They have like 3 questions to ask you, and they have the same 3 questions all the time. Yeah. So
On your website,
yeah. So when was it? Okay. So there's that one. Okay. Cool. So how many of you do special events at your museum where you try to get lots of people in to make lots of money? Lots of folks do that. Okay. We have lecturers that will come to your place and give you a nice, high-quality talk, non-technical talk for general public audiences and it costs you the big, huge, whopping sum of free.
Wow.
Free. So if you're doing any special events like Astronomy Day and you want a speaker who talks about the Earth, we got speakers. So, and we still have a few slots available for the fall of this year with these two speakers. This is certainly a good talk, how the eastern U.S. was built and why you should care.
It's spooky.
So good stuff. So if you want a speaker for an event, give me a call.
Do you have anything on supervolcanoes?
We have mitigating disasters, and we have how the southeastern U.S. was built. So not this year. Not this year. Okay, so there we go. Okay, and we also do public displays. So if you're looking to increase your earth science exhibits related to earthquakes, we have content that we can give you for free that if you provide the hardware, the computer, the screens, you can have a real high quality exhibit very quickly with it. This is in the New Madrid Historical Museum. They just did their museum. It was basically a house that someone lived in with all non-interactive stuff that was in the house when they died, basically, and other stuff that people gave them. And then they said, well, this 2011, 2012 is the 200th anniversary of the earthquakes happening. We'd like to have something different. So they built this huge interactive exhibit on earthquakes. It's the only thing that's interactive. It's great, but they're in sort of it's run by volunteers who were alive when the earthquakes happened. But it's good stuff. This is at the Smithsonian, and this is at the American Museum in New York. So cool stuff. We have interactive and non-interactive stuff, and I can show you one of them at the end. So our interactive exhibits. Oh, I'm going to talk more than that because I'm last. You got to wait till I'm done to get door prizes. So I know you won't leave. But I'll go quickly with stuff. So the interactive exhibits, the Active Earth Monitor runs in a web browser. So it runs on PC or Mac. All you got to do is go to the URL for the content, save that as your home page, run the browser in full screen mode, and you've got an exhibit you can plop down with stuff. Each of the pages are done as HTML web pages, so if you have anybody on staff who can design a web page, you can make content for it and insert your own content. And we've got about 6 different content sets now. Basic earthquakes, Pacific Northwest for subduction zones, San Andreas, New Madrid, EarthScope for East Coast stuff. And some of the pages you can actually put in the seismic station in US Array that's closest to your museum and see the data from 24 hours past for the one closest to you. So live data in your exhibit for free, plus the cost of a computer and a screen you had lying around with it. Okay, so how can you set it up? You could do it as a flat screen here, like Drew Gilmore's enjoying at TELUS. You can do it as a kiosk from a kiosk company already built for you. You can run it on a computer lab if you're doing a summer camp with kids. Let them explore the content and do an activity with them. Or you can set it up as a sort of a touch screen and a non-touch screen. A lot of ways to do it, depending on what you want to do. And we also have a free kiosk loan program that we've been running for the past couple years. In the region where US Array currently is deployed, we've got about a dozen kiosks that we've loaned out to folks. Iris pays all the shipping. We give it to you for a year. Here's all the places that have hosted it so far. All the light blue ones are where it is now. So how can you get one? Well, next year, if you're in one of these states, probably some NAPS folks are from a few of those states. Yeah. In December or January, I'll put a notice out on Domel at least a few times saying apply for it. You get the kiosk for a year. There's also an exhibit sign that goes with it too. That I got really, so we just made them with it. But yeah, so a free exhibit for a while, and you get live earthquake updates. If you want to find us, we're a lot of places. Go to the website. We do Facebook, we do Google+, we do Twitter, we do YouTube. We post new things. One of the newest things that we'll be doing probably end of July is a Google+ Live Hangout on earthquakes. And these are geared towards people who don't know crap about earthquakes, period. So they're going to be very simple. So what is an earthquake? What is magnitude? What's a seismometer? How does a seismometer work? How do tsunamis work? You know, very, very simple, short stuff using our animations. So if you don't know anything about earthquakes, you can follow the webcast and the archive and learn about earthquakes by watching all the videos once we make them up there. All right, and if you really, really want to learn something, EarthScope has done a series of interpreter workshops for informal educators and national park staff. The next one is September 16th through 18th up at Acadia National Forest in Maine. EarthScope pays all the fees for the conference if you can get there. So you pay the travel costs. EarthScope pays the hotel, the meals, and stuff. So 3 days learning all about East Coast geology, paid for by EarthScope. So if you've got some free time in September, and you can head up.
That's next year, though.
13. Should be 30. That's this year, yeah.
This year.
This year. Yeah.
Subtract one from every year, you tell us.
Yeah, so 2013, sorry about that. So that's this September, coming up. So if you're free this September, go to the EarthScope website, earthscope.org, and you'll see the link there for educator workshops, and you can apply for that. And we've had quite a few planetarium folks come to workshops, and they've enjoyed it. So
That's also a dark sky side.
yes, very, very dark.
Incredibly dark.
Very dark. Okay, so that's that. So very quickly, since I had to wait to go last, and you're a captive audience, like 2 more minutes. Okay, so our non-interactive public display looks like this. It's a bunch of maps that are hooked up to the internet, so you get live earthquake data. So each of the dots, the circles, is an earthquake. There's one that happened yesterday, and it flips through a bunch of maps. So there's the U.S. There were some earthquakes in California, the red circles, today. And you can pick and choose what maps you want to run.
I trust these are all low value force on these earthquakes. Or do we send condolences?
No, we don't. Those are like magnitude 2 or 3, so they happen every day.
The magnitude shown by the diameter of the circle.
Yeah, so it actually runs in HD. My computer monitor does not do HD, so it's kind of partly cut off. But if you have any, how many folks have a view space set up? You have an earthquake channel set up. Did you know that? Turn off view space, turn on our software, and you've got an earthquake exhibit. So when there's a big earthquake, change it over to earthquake channel, let the press come and the museum visitors for a few days, and then put it back on view space. So it just needs a computer, internet connection, and a flat screen. That's view space. So multitasker stuff. Okay. And then something that's not really Iris. If you haven't heard about it, you should take advantage of it because it's also free, and it does have sort of an Iris connection. How many folks know about Coursera? Free online university courses that you can take. Yeah, Coursera. Costs nothing. It's free. And here's just some of the courses I'm signed up for. One that's starting this week, Volcanic Eruptions, a Material Science. So you want to learn all about volcanoes? There's a course on volcanoes. From the Big Bang to Dark Energy, taught by the University of Tokyo. And slightly further down is a course called The Dynamic Earth, a course for educators, taught by the American Museum of Natural History. Ed Mathis, who's teaching that course, was on our Education and Public Outreach Standing Committee. So it's kind of got an Iris tie-in with it. And these are totally free. So you can log in, there's video lectures you listen to, and there's quizzes and assignments that you take. And when you're done, you get a lovely frameable certificate.
Acceptable by school systems for PDPs?
Some of it is. You can actually, if you do pay for it, they will give you an official transcript that confirms that you yourself took the course with it. So
You can actually see how far you've gone. Is that what that?
yeah, so it tells you how long the course is, and they're pretty cool. So, like for example, I took a Python programming course from Rice University, and I got a nice little certificate to put on my wall. I don't know that I can program in Python any better, really, than I could before. But the cool thing was, for that class, they actually taught it from a games perspective. So you had to do your programming to build games. And one of the games that we had to build was an asteroids game.
Nice.
So you learn programming by building an asteroids game. Yeah. So that was the stuff. And they're really good. They've got high quality folks teaching them. And if you get halfway through the class, you don't have time for it, you can unenroll from the class, and there's no penalty for it because you didn't pay anything for it. And they've got all kinds of subjects. You know, biology, education, science, acoustics, math, computer science. So if you get a chance, check out Coursera. Coursera. So cool stuff.
All right, we want some stuff.
Yeah, so lots of free stuff. Yes?
Now, the system of the small seismometers that are in school, is that a part of IRIS?
That's a part of IRIS too. I didn't talk about that. That's our Seismographs in Schools program, where we actually have non-professional seismometers that can detect, I think it's magnitude 3 or higher earthquakes from around the world, that you can get for your museum and have your own seismometer in the building. So your seismometer can detect the earthquakes in there. And we have a couple versions of it. One has a slinky in a tube, vertical tube. And one has sort of a lever arm with it. And they're about $200 or $300 for those. So you can set up your own seismometer. We have way more stuff on our website than I talked about. So head to the website, iris.edu. And if you have any questions, email, call, stop by.
Are there other countries that are doing something similar? Are there more seismometers worldwide?
Well, surprisingly, this will be sort of my end here. IRIS started 25 years ago under the thought that we'd really like to have all of the seismic data we collect freely available to folks, so that it's cheaper for folks to analyze data. More folks will look at it, more eyes on the data, so smarter folks than people who collect it are going to discover something in there. And 25 years ago, everyone said, that's not going to work. Yeah, no, I've got my data, and I'm keeping it until I've squeezed everything out of it, and then I'll give you the crumbs that are left with it. But a lot of folks who started IRIS really said, no, we're going to do this. And now you're probably thinking, well, what's the big deal? That's what we do with stuff. The Sloan Digital Survey is all available online. A lot of the Hubble stuff is available online. There's thousands of Hubble terabytes that nobody's looked at yet that you could learn that software to do the image processing, the FITS stuff, and get pictures that Hubble folks haven't had time to do. So when they proposed EarthScope, folks said, hey, that's not going to work. Because you can't possibly put 200 stations in the ground, professional quality stations, sit them there for 2 years, have it collect data 24 hours a day, 7 days a week, not lose any of the data, and then pick the thing up and put it somewhere else like 10 times. Yeah, it's not going to happen. Well, we had done good stuff before that, so NSF said, well, we'll give you money for 200 of them to put in and see what happens. And it worked out really well. And the siting for the stations is actually done by undergraduates in the summer at colleges that are in the sections where we were. Let's see, who from around here? I have to go back to my slide, but like Virginia Tech, College of William and Mary did Virginia, and West Virginia for us. And we gave the students the information, a GPS unit to go out. Here are the requirements we need for a good site, not near a road, not near a railroad track, that kind of thing. And then they would cite the sort of preliminary potential locations, talk to the landowners, and say, hey, we're going to bring this thing out. It's about from here to the wall with solar panel for 2 years. Do you mind doing that kind of thing? And folks said, yeah, you can't have undergraduates go out and do talk to people. They're undergraduates. They don't know anything about research. But it worked out really well because the undergraduates were very excited because now they're involved in a real research project. And they're out, finding out that maybe geology is not what they want to do because I'm walking out in fields with a GPS and I thought I'd be doing something different than that. So it works both ways. And there's folks that got very excited about doing it.
Other countries,
to answer your question, after we did ours, it was so successful that there are other countries that are modeling large geology projects on EarthScope. So China is a good example. They're doing ChinaScope, what they call it, where they're doing the same exact thing. They're getting a huge array of seismometers and they're moving it across the country.
And all the data is being shared, or will be.
We hope. At least for all of our stuff, it's being shared for folks. So you can go online within 15 minutes of an earthquake happening and get all the data from that earthquake and analyze it yourself if you want to.
NSA can hack it.
Yeah. So, but for China, they're not quite up to that because they're like, oh, but we paid for this, so we keep it for ourselves. Well, no, it's better. Yeah. So we're hoping we're pushing that for it. But yeah, other countries are doing that too. So we're trying to get better high resolution coverage. Hopefully, the whole world.
Is there any sort of equivalent programs for weather and climate change?
Maybe. I'm not a meteorologist.
He's an earthquake guy.
I'm an earthquake guy. So I don't know.
And what about volcanism?
Well,
The two are connected.
yeah, they are connected. Another part of EarthScope involves not seismometers but GPS units. And we've got a lot of GPS observatories, places like volcanoes,
Motion.
where they measure the motion of it moving up and down very precisely. So you can actually see the magma filling the chamber up, and you can see snow loading on the volcanoes in the winter because it squishes it down. So yeah, so that's it. So.
Thank you.